Okay, yesterday we taught you the basic substitution principles for the exponential functions and the logarithmic functions for your antiderivatives. Today we're going to talk about the antiderivatives for the inverse trig functions. My guess is that most of you won't remember any of these, but we'll review them and hopefully you'll pick it up in a little bit. Do you remember what the derivative of arcsine is? 1 over the square root of 1 minus x squared. Do you remember the derivative of arc cosine? Yep, same but negative. Remember the derivative of arctangent. All right, we got a race going on here. I like it. Arc is like inverse tan. So same thing as, same thing. All right, remember the, well, arc cotangent, obviously you guys know is negative 1 over 1 plus x squared. So how about arc secant? Yep. 1 over x root of x squared minus 1. Yep. What do you think? No. Oh, there are no notes on this test. So, all right. So let's try to find these antiderivatives. So here's the rule: the antiderivative of 1 over 1 plus x squared dx is arctangent or tangent inverse of x plus a constant. And the antiderivative of 1 over the root of 1 minus x squared dx is arcsine. And the antiderivative of 1 over x roots of x squared minus 1. So those are three that you want to keep in mind and remember. You can't say that. Like, you can't say it was a straight class or a straight face to have people take you seriously. You can't. You can't say you're going to fail this class with a straight face and have people take you seriously. That doesn't work. Nobody believes it. Raise your hand if anybody believes it. They're lying. They don't believe it. You can't get a 98% in the class and then say you're going to fail it. It doesn't work. 96, 95. Can't do it. You won't get sympathies for getting A's, folks. Okay? All right? There's a lot of people out there pulling to try to get B's and C's. So if you're getting an A, it's tough to feel bad for anybody. Here we go. Integral 8x over the root of 9 minus 16x to the fourth dx. The question is, can you figure out what the heck u is? Excellent try. Unfortunately, that's not it. The first thing that that's not it either. That's not it either. You can't, you guys have great, great thoughts. Okay? They're excellent. And everything you said is a good suggestion. Unfortunately, none of it's going to work. The first thing that you need to do is identify which form does it fit. It fits arcsine. Is everybody convinced of that? Okay. So what I'm going to do is I'm going to write down the form of arcsine first. Arcsine would be 1 over the root of 1 minus u squared du. So everybody agree that that's what I want to come up with. I have many things in the way of me obtaining that. The first one primarily is the 9. I need a 1. I need a 1. So I'm going to factor a 9 out of the bottom. Watch what happens. I have the integral of 8x over I'm going to write it all out for this first time. 9 times parentheses. Instead of 9, what will you have? 1 minus 16 over 9, x to the 4th, dx. Is everybody okay with that? It's hard to see where it's going, but you're going to see in just a second. I now have the integral, 8x on the top, on the bottom. If you move the 9 out to the front, what are you going to get? Everybody agree you have the 3 there. One minus, and now we have to decide what is being squared. 4/3 x squared is being squared, correct? 4 over 3 x squared squared. Now, look at the form that you were trying to obtain. 1 over the root of 1 minus u squared du. What is u? U is equal to 4 over 3 x squared. What is du? Hey, do you have an 8/3 x dx? Do you see it? Isn't that convenient? So therefore, we have the integral. I'm going to put down du. When I write down du, what goes away? You have 1 over root of what is the antiderivative of 1 minus 1 over 1, the root of 1 minus u squared? Of u. What is u? Pretty cool, huh? Yeah. Okay, please look at number 2. You notice that you have an x squared on top and x cubed on bottom, that those would cancel, but it's intentionally written that way to help you out, because if the problem is written as I just wrote it with just an x out there, it becomes very challenging for a lot of people. And I'll show you why in a second here. All right? Can somebody identify the form for me? This is arcsecant that we're looking for. So we are looking for the integral of 1 over u times the root of u squared minus 1 du. So that's a good idea. If you take out that x to the 4th, then you come up with the x squared, right? But if you take out the x to the 4th, you'd have to take it out of the minus 1 as well. And that's not going to help us then. So let's think about, what are we squaring? x cubed. So I can rewrite this as the integral of 3 over x times the root of x cubed quantity squared minus 1 dx. Now look what happens here, folks. Okay? What is it that you're squaring? You're squaring x cubed, correct? Well, so would everybody agree that we want u to be x cubed? Well, that means I need to have an x cubed out front, don't I? I don't have an x cubed. I did. I did, right? It says u is here. U has to match with whatever I'm squaring. You're squaring x cubed. I need this to be an x cubed. So can I just do this? Add an x squared in the denominator and an x squared in the numerator? Isn't that, I multiply the top and bottom by x squared? Right. I'm showing you that the original way it's set up, whenever I do that, everybody says, well, that's stupid because you just cancel out the x squared and the x cubed. Well, the reason why it's set there is so that you understand this piece. Is the x cubed there? It sure is. So somebody tell me, what is u in this situation? X cubed. What is dx? 3x squared dx. Do I have a 3x squared? I do. So now I have the integral. What do I have instead of the 3x squared dx? Whoops, sorry, du. And so then I have 1 over, what do I have in place of x cubed? U. What do I have in place of x cubed? U, and then squared minus 1. Do you know what that is? Arcsecant, or secant inverse of x cubed plus a constant. Yep. No. Oh, wait, it should be minus there. It should be minus there. Yep. Good job. These are going to go quicker now. Number 3, which form? Arcsine. Integral of 1 over the root of 1 minus u squared. Everybody agreed? That's what we're going towards. So what should we factor out of the bottom? Factor out at 25, and I get the integral of 20x cubed over, when you factor out the 25, what will happen? What will it become? 5. Root of what? 1 minus x to the 8th. Good. Do let's realize is that we have an x to the 4th squared. So 20x cubed over 5 roots of 1 minus x to the 4th squared dx. Let's simplify that 20 over 5. How's that? 20 over 5 is going to become just 4x cubed. What is u? What is du? Great. So now I have the integral of du on the outside, root of 1 minus u squared. And good. How about number 4? Everybody see its tangent. There's no square root sign. So I'm looking for 1 over 1 plus u squared du. I need a 1, and I need something squared. What are you going to do? Okay. So I got the integral of 10x over 16 times 1 plus 25 over 16 x to the 4th. I could simplify as 10 over 16, right? To what? So I raise 5 over 8 times that x over 1 plus what squared? Good. So what is u? So I said, what is being squared? This is a perfect square, right? I just took this guy right here, 25 over 16. If you take 5 over 4 and square it, you get 25 over 16, right? If you take x squared and square it, you get x to the 4th. So I just took this guy and wrote it as a perfect square. You have to write it as a perfect square. I just wrote the 10 over 16 as a 5 over 8. If you want to leave the 5 on top, that's fine. If you want to pull the 5 over 8 out front, you can. You can do anything you want with your multipliers. What is u? So what is du? 5 over 2x dx. Do I have a 5? Do I have an x? Do I have a dx? Do I have a divided by 2? What do I have? Divided by 8. So I must multiply by a 4th. So 1/4 du is equal to 5 over 8x dx. Integral 1/4 du. This is where I start crossing stuff off. Otherwise, I make mistakes. I go too quickly. What do I get rid of with that 1 over 4 du? 5/8. What else? Dx. What else? X. So I have a 1 on top over what? 1 plus u squared. What's the answer of 1 plus u squared? So 1/4 arctan of 5 over 4x squared. You're doing really well. Be scared by the next one? It's just cosine, they say. What's the form? I'm going to encourage you guys to never use the negative ones. Only use the positive ones. Only use arcsine, arcsecant, and arctangent. Just write the result as positive or negative. Okay? That's the way I see it expressed if it ever comes up in the AP exam. So we need a 1. We know that it's going to have the form 1 over the root of 1 minus u squared du. Kitty already identified. We're going for, she said arc cosine, which would be a completely valid option. But in order to reduce our number of opportunities, just go to 3. Just go sine, secant, or tangent. And then if it just ends up coming negative, then it's negative. No big deal. So what are you going to factor out? A 9. When you factor that 9 out, what's it going to become? So I have a 3 root of of 4x over 9. Need to write my perfect square. What is it that we're squaring? Cosine of 4x over 3. I mean, it's ugly, but we've still got this, don't we? We've got the 1, we've got the squared. That's what's important. So, what is u? Now, we'll see how good your math teacher has been or not. Du is equal to, I have to take the derivative of this guy. What do I have to use in order to take that derivative? Chain rule. What's the derivative of the inside? 4. So you're going to have a 4 over 3. What's the derivative of cosine? So it's a negative 4/3 sine of, and what's on the inside? 4x dx. Do you have a negative 4 over 3? Yes. Do you have a sine of 4x dx? Yes. Isn't that nice? See why I told you to keep it as sine inverse, Katie? That's where you always default to. Don't default to those 3. I don't even list the other 3 in your notes because they really never seem to come up. And so here we go. We have the integral. I put down du. What do I replace with the du? What did I cross off? So what remains? And that's easy peasy. What is that? And what is u? Look at that. That thing is ridiculous right there. Arcsine of cosine of 4x over 3? Man, who would have thought? It's just a constant. You could write this as 1/3 cosine of 4x. If you put a 3x in the denominator, now it's the quotient rule. You have something that's changing here, but the 3 does not change. It is constant. Last one. What's the rule? Tangent inverse. So I'm looking for 1 over 1 plus u squared du. What will I factor out of the bottom? A 9. I'm going to choose to write it out front to just show you how a lot of people take care of their constants. I'm going to write a 10/9 out front. That's just how I roll some days. What's left in the top? X to the 4th. What's left in the bottom? 1 plus 4x to the 10th over 9 dx. Can I write that as a perfect square? You sure can. And I have 10/9 integral x to the 4th over 1 plus, what is that thing being squared? Yep. 2/3 x to the 5th quantity squared. So what is u? 2 over 3x to the 5th. What is du? Do you have a 10? Do you have an x to the 4th? Do you have a dx? Do you have it divided by 3? You got to divide it by 9. So what do I have to do? 1/3 du is equal to 10 over 9 x to the 4th dx. So I do the 1/3, I do the integral, I do the du. What do I cross off? Yep, the x to the 4th is gone, the 10/9 is gone, the dx is gone. What remains? What is the antiderivative of 1 over 1 plus 2 squared? Tangent inverse of. Wow, you guys are smart. Good job.